Hello everyone, my name is Chuck Lewin and today we're going to introduce you to PMD's latest product, the CME N-Series Digital Drive. If you have any questions during this presentation, we invite you to use the Q&A panel inside the GoToWebinar platform or to visit www.pmdcorp.com and then select Contact Us. In this presentation, we're going to start with a quick overview of performance motion devices and its products. Then we'll talk about what the CME N-Series Digital Drive is and what its capabilities are, and how its breakthrough benefits can help you in your next motion control design. Finally, we'll show several real-world examples that utilize N-Series ions to create the controls for different types of machines. Before we dive into the product details of the N-Series ion, let's talk a little bit about performance motion devices and give you some background on the company and its products. Performance Motion Devices, also called PMD, is a leader in motion control technology for life sciences, robotics, and industrial automation. PMD's motto, Motion Control at its core, reflects our unique and powerful strategy of placing motion control ICs at the core of all of our products so that they speak one common motion language. PMD was founded in 1992 and is headquartered in Boston, Massachusetts. PMD is an ISO 9001 and ISO 1345 certified company and is a motion partner of choice to the world's leading machine OEMs. PMD makes a wide range of motion control products from integrated circuits to modules to boards. All of these products support brushless DC, DC brush and step motors, and all of these products speak a single language, C-motion. We have two overall groups of motion control ICs. The Juno ICs are dedicated to torque and velocity control and provide industry-leading performance in a very cost-effective package. Magellan motion control ICs provide positioning control. They come in single and multi-axis versions and have been used successfully in thousands of different applications. Atlas digital amplifiers are high-performance dedicated motor amplifiers. Like many of our products, Atlas amplifiers are ideal for creating embedded, PCB-mounted control solutions. Ion digital drives contain a single-axis Magellan IC and then add onboard amplification. These modules are perfect for applications where you want a ready-to-go, plug-and-play solution. The N-Series ion, which is the focus of this presentation, is in fact a brand new member of this very popular product line. Finally, we have the Prodigy motion control boards, which again start with the Magellan motion IC, but are packaged in a board format. Prodigy boards come in both PC104 and standalone formats. Okay, with that introduction behind us, let's get started on the reason we're here today, which is introducing you to the N-Series ion drive. So what is the N-Series ion? Well, it's an all-in-one, very compact, single-axis motion controller that is mounted on a printed circuit board. It's part of the Ion Digital Drive family, but goes much further, having more power, more onboard speed, and more network connectivity. Despite these upgrades, it's much, much smaller than existing members of the Ion family. Using the N-Series ion is very easy. It's driven with a single voltage and requires no external circuitry to function. To use it in a design, you just create an interconnect board. This board connects the signals provided by the N-Series ion to the connectors that will interface to your motor and the motion peripherals. So now let's look at some specific capabilities of the N-Series ion, beginning with its patented ultra-compact package design. This design reflects PMD's extensive experience in embedded motion control. Its dimensions are as small or smaller than any comparable drive on the market at 37 by 37 by 17 millimeters. And it is easy to mount and heatsink. This starts with a metal plate and 4 mounting tabs to rigidly clamp the unit to a heat-sinking surface using 4 M2.5 screws. The top side of the unit interfaces to the interconnect board using a 44-pin signal connector and a 7-signal power connector. 4 alignment posts complete the interface. These soldered posts give you incredible connection strength between the ion unit and the user interconnect PCB. Finally, I want to discuss a unique feature of the N-Series ion mechanical design, the new substrate mounting method. With this mounting method, the chassis wall of the machine being used controls directly anchors the ion unit via the 4 mounting tabs and then supports the user PCB on the opposite side of the ion unit. Of course, you don't have to mount it this way. The opposite approach is called component mounting, with the ion mounted on the top side of the PCB and typically using air-cooled heat sinks. At the core, the most important capabilities provided by the N-Series ion come from its Magellan motion control IC. The Magellan IC used in the N-Series ion is our fastest ever, providing a position and servo loop rate of 20 kHz and adding new features like a brake signal input and dual biquads for dynamic system response tuning. As always, the motion IC that we put inside the N-Series ion speaks C-Motion, our award-winning motion control language. So do all PMD products. This means you can start with your design with an N-Series ion and migrate to other module products or board products or even IC level products without changing the software code you've written. Making the power of the Magellan IC easy and accessible is ProMotion, our Windows-based development environment. You use the Axis Wizard to connect up your motor and access peripherals, and then use an auto tuner to get your motor spinning quickly and easily. What would a motion drive be without an amplifier? Well, the N-Series ion state-of-the-art onboard digital amplifier doesn't disappoint. 3 power levels are provided: 75 watts, 350 watts, and 1000 watts. This lets you select the ideal power level for your application. You can drive a power-hungry robot axis with 20 continuous amps or deliver just milliamps for extremely precise control of a microscope inspection station. And this powerful unit has brains as well as muscle. The N-Series ion lets you select a wide range of PWM rates and now provides a sophisticated space vector PWM output and field-oriented control for ultra-smooth, ultra-efficient motor operation, especially at high speed. Finally, we've incorporated multiple levels of protection into the N-Series ion to safeguard against overcurrent, short circuit, over temperature, over and under voltage, I2T, shunt control, and +5 output overcurrent detect. PMD introduced its first ion with an onboard C-Motion engine in 2014. It was an instant hit. The reason is that the C-Motion engine, which we call CME for short, doesn't just sequence motion commands or use archaic 2-letter codes for the language. It's a real standalone microprocessor fully under the control of the user. With this new version of the C-Motion engine, we've increased the CPU speed, added multitasking, and expanded the user program as well as the RAM space to 256 kilobytes. What it all means is that there will be very few applications you can't handle with the C-Motion engine. It's a full-born C language processing machine, has plenty of speed and plenty of memory. It will let the designer build exactly the motion controller they want without restrictions. Each N-Series ion comes with a choice of either Ethernet, RS-232, RS-485, CAN, or SPI host connection networks. But connecting to the host network only gives you half the potential you need to build a full application. That's where a truly unique and powerful new feature comes in called expansion networks. Each N-Series ion, regardless of host network type, comes with 2 additional network connectors called expansion networks. These networks are the key to building machine controllers that can operate on their own, and they are especially useful for building multi-axis controllers. We'll look further at this exciting capability a little bit later in the presentation, but for now, remember that the N-Series ion units, despite being so small, have all the connectivity options you need to create any motion solution. One of the fastest developing areas of motion control is encoders. It seems that every year, new encoder types and formats are released. Managing these new encoder formats is not easy, but the N-Series ion does the heavy lifting by adding support for BIS-C and SSI encoders and sine-cosine encoders. The N-Series ion's sine-cosine circuitry in particular has been designed for maximum performance. To begin with, it can interpolate by a factor of up to 16,384. In addition, it can improve the quality of the analog signals from the encoder. These signals can often be affected by noise or other distorting factors. The N-Series ion provides a sophisticated correction scheme that uses algorithmic adjustments of the incoming signals, such as signal gain scaling, signal phase shifting, and several others. The result is smoother, more accurate motion, and better positioning accuracy from the sine-cosine encoder. Okay, now that we know what the N-Series ion can do, let's focus on what really makes it special. What features are the true breakthroughs, enabling a whole new way of building motion controllers and solving motion control problems? Perhaps the biggest breakthrough that the N-Series ion enables is the ability to create application-specific controller boards incredibly fast. In the past, the only way to create a fully custom embedded motion controller board was to build the board from the IC level components. This is typically at least a 6-month engineering process and requires high-level electrical engineering knowledge. N-Series ions let the designer build the same board in weeks, not months. Take a look at the boards in these slides. They were very simple to create because the interconnect board has no active components on it. You aren't designing a schematic, you're designing a wiring diagram. And the boards don't have 6 or 8 signal routing layers, they have only 2. Despite how quickly these boards can be created, the result is still a complete, high-performance motion controller. This is because each N-Series ion is a fully self-contained, fully ready-to-go motion control module. Just give it a single HV voltage and the ion will do the rest. Drive the motor, input the encoder signals, run the application code, everything. To illustrate, let's look at an actual project design example. We're going to build an XYZ Gantry controller using 2 different methods and then compare the results. The N-Series ion base board uses, of course, 3 N-Series ions, 2 of brushless DC type and 1 of step motor type. The IC base board will use 3 MC58113 ICs from PMD. The MC58113 is one of the most popular motion control ICs in the market today and is used in thousands of designs worldwide. Okay, so let's look at the resulting designs. You will see a rendering and then dimensions for the motion controlled IC board first, followed by the N-Series ion-based board. Notice that the N-Series ion board is a little smaller. This is because internally it stacks components that would otherwise be spread out in the IC-based approach. In terms of the development project time, as expected, the design time is also much, much less with the N-Series ion, 6 weeks instead of about 6 months. Does the motion IC approach have any advantages? Yes, it does. The per unit production cost. This cost is about half of the N-Series ion approach. Both the MC58113 IC and the N-Series ion are great products. They each have their strengths, but what this example shows is that the N-Series ions provide something completely new, the ability to create application controller boards much faster than ever before. Don't forget, by the way, that a hybrid approach is also possible, creating a controller board using N-Series ions to support early machine prototypes and in parallel, building a board with motion control ICs for lower per unit production cost. Since they both speak C motion, code written for the N-Series ion also works with the MC58113 ICs. Another breakthrough feature of the N-Series ions is that it supports 2 different network connection schemes, flat and hierarchical. Every other comparable device on the market supports only one. A flat connection scheme means the motor drives operate from the same command level, controlled by a single host. CNC machine tools are a classic example because each axis must be synchronized very precisely and all in parallel by a central controller. but other machines also follow this popular connection model, including XYZ stages, robot arms, plotters, and others. A hierarchical scheme means that there are subnetworks within the machine controller. A subnetwork does not directly attach to the host network, so it allows the drives to communicate to each other without impacting host traffic. Just as importantly, the subnetwork can use a protocol different than the host network protocol. Laboratory automation is a classic example of a hierarchical scheme. In a big analytical machine, such as a blood analyzer, there might be 20 or 30 axes altogether. The hierarchical approach makes it easy to group control of axes together by their function. On the N-Series Ion, the hierarchical scheme is enabled by the expansion networks. As we mentioned earlier, there are two expansion connections, an SPI and a CAN network. Expansion networks are brand new for the Ion product line and one of its most exciting and useful new features. To illustrate, let's look at an example of how hierarchical control is used. We want to build a liquid handling platform with 12 axes. The axes are broken up into 3 subunits, a 2-axis microplate shaker, a 4-axis SCARA arm controller, and a 6-axis syringe control unit. We could certainly wire a flat 12-axis network and have the host command each of the 12 axes directly. But that would be awkward from a control perspective since the function of, for example, the microplate shaker is unrelated to the function of the SCARA arm. So instead, we're going to use the N-Series Ion to build 3 separate controllers, each on a single multi-axis PCB. Each control board will have one host-connected ion that also controls an axis. In addition, the host-connected ion will connect via its expansion network to the other axes. User-written code executes on the host-connected ion to parse the host network commands and drive the controlled axes based on the received host command. In the end, the main advantage of the hierarchical network connection is simplicity of the control software. Hopefully, this example shows that when the control problem and the control solution are aligned, the result is a simpler design effort and a more reliable machine. Another breakthrough benefit of the N-Series Ion is that it greatly simplifies the transition from a traditional centralized control approach to an embedded local control approach. The main benefits of embedded control are smaller size, lower cost, improved reliability, improved performance, and a simplification of machine installation. Instead of a machine as well as a box to install, the customer just installs the machine, and the controls are embedded somewhere inside the machine. The transition toward embedded controls has been a slow trend for quite a while now, but in making this leap, there is a price to pay in terms of upfront design. Going embedded generally means designing a custom controller board to replace an industrial computer or PLC-based setup. And that's why the N-Series Ion is an ideal device to facilitate this transition. For companies considering the jump to embedded, but not experienced in building custom boards, the N-Series Ion greatly simplifies this task. Let's again use an example to show how the rubber hits the road on going from centralized traditional to embedded control. For this example application, we're going to borrow a project we're already familiar with, the 3-axis Gantry controller. We're going to leave out a lot of detail here and just get a feeling for the impact on the controller size and ease of assembly. First, the PLC solution. PLCs are a great approach for motion control, but ultimately they come in standard shapes and sizes only. The big impact for us will be on the connectors. PLCs typically use jack screw connections to interface with the outside world. This makes wiring up the machine flexible, but time-consuming and error-prone. Next, the N-Series Ion solution. As usual, we need to design an interconnect board. Although this is more design work for us, the big benefit is that now we can choose the exact combination of jack screw and pre-made cable connectors for the application. This will simplify and speed machine assembly. Comparing other aspects of the two solutions, the biggest difference by far is the size. The volume of the box, PLCs and DIN rails ends up being about 10 times the volume of the N-Series Ion-based control board. That is a really big difference, and ultimately what makes it possible to locate the controls on or inside the machine. To close this example out, remember that when you talk about moving from the PLC world to the embedded control world, other factors come into the picture, especially the programming language. PLCs tend to be programmed with ladder logic, whereas N-Series ions are programmed in C language. That's a big jump for a shop that's not familiar with C language. Ultimately, though, PMD has worked with many clients who have made the jump from PLC or industrial computer-based controls to embedded controls. The benefits we see again and again are a more compact design, a more reliable design, and easier siting and installation of the machine at the operations site. Okay, to close out today's presentation, we're going to show you a few different projects that use N-Series ions to solve different motion control challenges. These will give you a better sense of how to use the ion in real-world applications. Let's take a look. Our first design is a controller for a centrifuge. This is a relatively easy design to accomplish with an N-Series ion. User code is loaded into the ion, and this software coordinates the entire function of the centrifuge, handling button presses by the user, LE indication, and other peripheral control functions. The 15 amp drive requirement is well within the N-Series ion's current output rating. The brushless DC motor control mode will be field-oriented control to give us high speed and efficient operation. This application also shows off the substrate mounting method, with the controller board being embedded inside the centrifuge unit. In addition, it shows the ion's capability for 100% standalone operation with no host communication or supervision. We've already seen this project in some of our previous slides. It's an example of a multi-axis board-based controller using N-Series ions. The Gantry operates as part of a larger laboratory analysis machine and is commanded via an Ethernet link. The Ethernet link carries high-level commands such as move Gantry to location XYZ. User code that has been downloaded into the host-connected N-Series ion interprets these commands. So this is an example of the hierarchical control approach enabled by the N-Series ion's new expansion network port. In addition, this project shows off other features we've talked about, including the substrate mounting method, the small size of the resulting control solution, and transitioning to embedded control. This application represents a broad class of single-axis motor controllers used in robotic joints or in mobile applications such as factory warehouse robots. Although we've shown the solution PCB mounted on the robot arm, it could also be mounted right in the back of the motor. Does the extra weight of mounting the ion on the arm slow it down? Very little. The weight of an N-Series ion is only 1.2 ounces or 33 grams. This project shows off another feature we've talked about, which is the use of flat connection architecture. In this application, a high-speed CAN FD host network is used to coordinate multiple robot arm axes in parallel. And finally, this project demonstrates the ion's high power output. With output of more than 1 kilowatt, N-Series ions can easily drive NEMA 23 motors and even most NEMA 34 motors. The final application that we'll look at is a little bit different. The main difference is that the controller PCB has a lot of local components on it. In the previous three applications, there were basically no active components on the controller board other than the N-Series ions. This project also shows off some of the other features we talked about, including use of the SPI expansion port. But in this case, we don't use the expansion port to talk to the other N-Series ions. We use it to talk to an FPGA. This FPGA assimilates a large number of digital and analog input signals, more than 8 digital IOs in single analog input that the ion natively provides. So here, we use the expansion port as a way to expand the peripherals that the N-Series ions can talk to and control. Well, that completes our presentation for today. We hope you enjoyed learning about the N-Series ion digital drive and its various capabilities. We invite you to visit our website, www.pmdcorp.com, or to call us at 978-266-1210 to learn more. Thank you for watching. and have a great rest of your day.